So let's talk about a couple different types of 3D printer filament. Now, something to remember too is when you're budgeting for a 3D printer, don't forget to budget for future filament purchases, because obviously filament's going to be an expendable resource. So you need to replenish those supplies. And so when you're budgeting, always remember there's going to be future filament purchases. Now, there are some great filament brands that are available on Amazon. And so you can find a 1 kilogram spool of 3D printer filament for about $20 a spool on Amazon. There are some great filament brands that are good. Overture is a great 3D filament brand. Hatchbox is another really good 3D filament brand. And to put it into perspective, my human life-size skull here is about maybe 1/4 of a 1 kilogram spool. So the spools go quite a long way. Now, the most common 3D printer filament is PLA. And so if you're on the slides here, if you click on any of these links on slide number 20, they will take you to a dedicated page all about that filament. So, do a little bit of research, but understand that PLA is the most popular, the most commonly used. If you're using 3D printer in the classroom and you're not a CTE teacher, it's what you will use probably 95% of the time. It's easy to print with. It is a low temperature filament, so it prints somewhere between about 180 and 230 degrees Celsius. Remember, everything here in 3D printing is the metric system, so it's a great metric system lesson as well. Next, we have PETG, PETG. Now, PETG is kind of a really cool in-between ABS and PLA. ABS plastic is very, very strong, but not easy to print with, and it gives off fumes, so typically not very classroom friendly. PETG is kind of the middle ground between PLA and ABS. PLA is great, but it can be brittle. So sometimes if you drop an object, it could break. It's not super heat tolerant. So if you leave a PLA printed object in a hot car during the summertime, it could not melt, but definitely droop or sag. PETG is stronger. It's a higher temperature printed filament. It handles higher temperature tolerances, and it's considerably stronger than PLA. However, since it is a higher temperature filament, it can get stringy. It's not always super easy to print with. It's more of an intermediate kind of printer filament. So start with PLA, and then you can kind of maybe graduate up to PETG. Please understand, though, that PETG sticks down to your print bed much more strongly than PLA. So be careful when you're removing a PETG from your print bed that you don't damage the print bed itself, because the print beds typically have either a metal or a glass sheet that you print on. Some of these steel sheets that we use on the printer beds have like non-stick coatings on them, and that PETG sticks so well that it can maybe rip off that coating. So in some instances, you might put a layer of glue stick down to be a release agent to pop that print off. Other times you can take the printed object on the print bed and stick it in the freezer maybe for a minute or two to help ease it off of the print bed. Okay, ABS is the most well-known plastic on Earth. It is what almost everything that's made out of plastic is. All of the plastic stuff that's in front of you right now, this second, is ABS plastic. ABS plastic is used for injection molded plastic. It's very strong. However, when you're printing with it, it gives off VOCs and fumes, so not for classroom use. You would need a vent hood if you were maybe in a science lab. If you are a CTE teacher and you're working in a shop, certainly a ventilated shop is going to be fine. Now, if you do print with ABS, that does require a couple things. It requires an enclosure, because you can't print with an open frame printer because you need a higher ambient temperature for layer adhesion. Also, it's a high temperature print, so you print at a much higher temperature, and it does give off fumes. So again, you need an enclosure and you need ventilation. So ABS is definitely a much more advanced level kind of plastic. But if you are a CTE teacher, if you are teaching engineering and you want to build for structural strength, ABS would certainly be the way to go. Last, we have nylon. Nylon, again, is very, very strong, even stronger than ABS, but tricky to print with, stinky, gives off VOCs and fumes, and does have layer adhesion issues. So you need an enclosure, you need a higher ambient temperature, you need some experience at printing. But again, in the engineering classroom, in the CTE classroom, in the industrial tech classroom, nylon would certainly be a great material to print with, because you can print functional structural objects. Again, you do have more options than this too. You have many kinds of infused filaments as well. There's carbon fiber infused filaments that are super, super strong. But some of those infused filaments can be abrasive. So you need a hardened steel nozzle rather than the typical brass nozzle that's on a 3D printer, so that the filament doesn't abrade the nozzle from the inside out.